So this question came in JEE Advanced 2025. So let's see how we can evaluate this question. But for that, please do like, share, subscribe, and please support this video. So this question seems to be difficult at first sight, but I don't think so that it is that much difficult. So what we can do? Well, at first sight it seems that we have a trigonometric function, an inverse trigonometric function over here, and an algebraic function over here. So we can think that maybe we can apply integration by parts, but I don't think so that that would help much, because it would make the things more messed up. So what I'm thinking is that it would be very much simple if I use some substitutions and some inverse trigonometric identities. So let's see what I'm talking about. So first of all, let's assume this expression tan inverse x divided by 2x square minus 3x plus 2 dx, we let it to some I, right? Okay, so now I see a 1 by 2 and a 2. So I get a hint. What hint? That if I assume x as some 1 by t, then it's possible that I can change this function a bit without changing the limits of the function. What I'm talking about is that when I use x as 1 by t, the limits will go from 2 to 1 by 2. Tan inverse of 1 by t, 2 into 1 by t square minus 3 into 1 by t plus 2. And what is the derivative of 1 by t? So dx is equal to negative 1 by t square dt, right? Okay, so this will be dt by negative t square. Now we see a negative sign, so we can make it plus and we can reverse the limit. So it will now go from 1 by 2 to 2, right? And there's the function now, and we can simplify it more. We will get the integral from 1 by 2 to 2. We can multiply t square with this denominator. We will get tan inverse of 1 by t divided by 2t square minus 3t plus 2 dt, right? Okay, and this is equal to I. And if I write I as integral from 1 by 2 to 2 tan inverse of 1 by x divided by 2x square minus 3x plus 2 dx. Are you all okay with this? Because we all know that if a function is going from a to b, f of a or f of x dx, you can clearly replace with it with some other variable, a to b f of y dy, right? Because clearly it's just a substitution. X is equal to y, so dx will be equal to dy and f of x will be equal to f of y, right? So clearly I've used this substitution because I like to see x in integrals more rather than another variable, because we are more familiar with x in integrals and calculus. So that's why y and x are mostly used in calculus, so that is why I'll be using x. And now what I'm going to do is that I'll add this with this, and let's see what we get. So we had got I is equal to integral, means first of all let me write this one, 1 by 2 to 2 tan inverse of 1 by x 2x square minus 3x plus 2 dx. And we had got another I as the integral from 1 by 2 to 2 tan inverse of 1 by x 2x square minus 3x plus 2 dx, right? Okay, so what can we do? Well, in such kind of problems we usually add both the integrals. So when you will add both of them, you will get integral from 1 by 2 to 2 tan inverse x plus tan inverse 1 by x divided by 2x square minus 3x plus 2 dx, right? Okay, so what can we do next? Well, we all know tan inverse of 1 by x is equal to cot inverse of x if x is greater than 0. Clearly the limit is from 1 by 2 to 2, hence we have this expression. and this makes this question bit easy. But as a challenger problem, you can do this integral now. Evaluate it from negative 1 by 2 to 2 of the quantity tan inverse of x divided by 2x square minus 3x plus 2, right? So how you will do this? Well, first of all, you have to break the limits from negative 1 by 2 to 0 negative of the quantity tan inverse x divided by 2x square minus 3x plus 2 dx plus the integral from 0 positive to 2 of the quantity tan inverse x divided by 2x square minus 3x plus 2 dx. So you can try this problem. It will be more useful because this is very easy problem. I guess it is very easy. This one will make it bit difficult, but that is also easy thing, not tough. Just the limits, we had to just break the limits. That was a tricky part over here. Rest everything is very easy. So if you want to make it more difficult, okay, leave it. You solve this problem and we will discuss more difficult problems later. Okay, so you can try this one. For now, let's see how to solve this one again. Okay, so we have this expression. So we can say, so we know the identity tan inverse of some alpha, or suppose some a, plus tan plus cot inverse of same input is equal to pi by 2. We all know this thing, right? So clearly we have, so it should be also equal to pi by 2, right? So this expression is equal to pi by 2, right? Okay, so I is equal to pi by 2 integral from 1 by 2 to 2 1 upon 2 x square minus 3x plus 2 dx, correct? Okay, so now how we can evaluate this? Well, let's see. Note one thing, it was 2i, sorry. So 2i, so I is equal to pi by 4 integral from 1 by 2 to 2 1 by 2 x square minus 3x plus 2 dx, correct? Okay, so we have to evaluate this integral. We had got this thing, pi by 4 into integral from 1 by 2 to 2 1 upon x 2, it was 2x square minus 3x plus 2 dx. So we have to evaluate this, and this is the answer. We have to evaluate this integral. Okay, so the integral is from 1 by 2 to 2 1 upon 2x square minus 3x plus 2 dx, right? So how can we evaluate this? When it is 1 upon quadratic form, if you don't want to remember any kind of forms, then you can just see that it is a quadratic equation, and we know how to solve quadratic equations, right? So it is from 1 by 2 to 2 1 upon, how to factorize it? Well, I will tell over here. 2x square minus 3x plus 2. You can take 2 as common, you will have x square minus 3 by 2 x plus 1, correct? So what to do next? Well, 2 into the quantity x square minus 2 into 3 by 4 x plus this quantity squared 9 by 16 minus this quantity, 1 minus this quantity will become 7 by 16, correct? So we get 2 times the quantity x minus 3 by 4 whole square plus 7 by 16, correct? So the final answer will be, well, let me write 2 x, sorry, it will be 1 by 2 x minus 3 by 4 whole square plus 7 by 16. So the final answer will be, this was that. So 1 by 2 into this will become pi by 8 integral from 1 by 2 to 2 1 by x minus 3 by 4 whole square plus 7 by 16 dx, right? So we will have dx also. Okay, so now let's erase this and let's see what we can do further. So we have to evaluate this integral now. 1 by 2 to 2 1 upon x minus 3 by 4 raised to the power 2 plus 7 by 16 dx. Now I see many students learning the formula that for such kind of integral that will be the formula, and for that integral that will be the formula. I don't think so that learning would help much. You have to understand the concept behind that. So, and I've seen many teachers saying, "Don't learn this formula. You have to learn this formula for your examination and all." But I don't think that is the right way of teaching, because I'm not teaching for any examination over here, for any JEE or for any NEET examination or any examination whichever you are thinking. I'm not teaching for that. I'm teaching for concept. So the method which I will be telling, it is for your conceptual building. If you want to learn it, it's your choice. But I would say that you should prefer the derivation of each formula, because if you just learn the formula, then it's of no use. You can crack the examination, but the most important thing is that you should have a conceptual understanding of a subject. So for that, I prefer to derive everything, right? And secondly, the derivation whichever I am telling, it is not necessary you follow that. Create your own derivations, and that is what will make you fall in love with mathematics, because mathematics is not something which you can rote learn and then you can score marks. Okay, you can get marks, but I don't care about marks that much. What I care about is the conceptual understanding of a person. If you are well acquainted with all the concepts of mathematics, that how things are working and how to apply it in real life, then okay. Because I've seen many people who have cracked many examinations and still they say, what is the use of mathematics, why were we studying it? But in reality, mathematics is everywhere. Even my hand motion, it is also mathematics. Everything in this universe is based on mathematics. But still, I've seen many people saying that mathematics has no role in their life. Whatever they have studied is just useless. It is useless for them because they never understood the concept of that, the beauty of that subject. I don't know why you are treating mathematics as a subject or physics as a subject. Take mathematics as a tool to understand this universe, this nature, and physics as something which helps us to understand that nature. So mathematics or physics or be it any subject whichever you are studying, every subject has some uniqueness in itself and has some conceptual beauty. But I don't know why people teach it like that it becomes very much boring. Students just keep on studying that subject for merely to get marks and other sort of thing. And I don't know why this is the case. I don't know why students are just studying that subject to get marks. I don't know why. You can get marks if you have knowledge. You can get marks if you have less knowledge also. It is not like that you will get marks only if you have knowledge. So what is the right way of studying anything is that to understand the concepts behind that, because if you don't know the concepts, you can get marks. It's not like that you won't get marks. You can learn formula, and many times you get formula based paper only, right? So in that case you can get marks. But what I want you all to do is to understand the concept and the beauty of the subject, because personally I never see mathematics or physics as a subject. They are like, how can anyone see them as a subject? They are so interesting if you try to observe it in nature. What maximum of us are doing is that we are just doing it for the sake of marks and like that. The thing is that if you are considering mathematics or physics or be it any subject as a burden to yourself, it's not your problem, it is the problem of your teacher first of all. And secondly, the fault belongs to you if you don't point out that thing. You are just following the trend, what everyone is following. Don't follow that. Just follow what you think is right and what logically makes the sense. Of course, taking stand for illogical things is also not a good thing. So, in a nutshell, if I want to explain what I'm saying, understand the crux of the subject, be it physics, mathematics, be it history even, be it biology, be it any subject, just go deep into it. Don't study it just for any examination or something like that. Once you start studying for your enjoyment and for understanding the nature of the universe and your surroundings, you will start loving that subject. And I can give you thousands of examples in your daily life only, that how you are using different subjects in your different works. And I don't think so that I should discuss it right now. I will make another video on this topic for sure, regarding all the subjects and why students are moving away from the concepts and they are moving towards rote learning. I'll make on this topic. So I think so that I should stop this discussion for now, else it would like the fluxinous nihilification of times. I think that a new video will be required for this topic. So for now, let's move to this thing. Okay, so we have this integral, right? But the key thing is that you should focus on derivations, on concepts, on understanding the nature on yourself. Whatever derivations I tell, it's not necessary you follow that method only. You can follow any method, whatever you want, okay? Because creativity is what is required for any subject. Once your creativity is gone, understanding subject becomes very difficult, right? So we have this thing. Yeah. So now what I'm going to do is that I'll go by step by step. So I can assume I see x minus 3 whole raised to power 2, right? So I can say x minus 3 by 4 is equal to some t, right? Let's assume it. So we have dx is equal to dt, right? Okay. So when x is equal to 1 by 2, then t is equal to what? 1 by 2 minus 3 by 4. So it will be equal to what? It will be equal to negative 1 by 4. So it will be from negative 1 by 4 to, when x is equal to 2, you will get 2. What you will get? You will get 8 5 by 4. Okay, divided by the quantity t square plus 7 by 16, right? Okay, so what else you can do? Well, I know one thing, that 1 plus tan square x is equal to sec square x, right? And derivative of tan x is equal to sec square x, right? So I see t square plus some constant square. So it is of this form, almost of its form, right? So if I say t is equal to some tan x, will it work? Clearly not, because here we don't have 1. So how we can make it 1? Well, if I assume t as 7 by 16 square root tan x, yeah, then it will work. Okay, so this is how I assume things, how I do things. I don't remember any formula, I just derive everything. Okay, and if you have learned anything properly, if you have understood something conceptually, the derivations don't take much time. It just take 30 to 40 seconds max to max, or it can just take 10 seconds only, right? If you have understood everything conceptually, right? So clearly we can see over here. So when t is equal to negative 1 by 4, negative 1 by 4 is equal to root 7 by 4. So x is equal to tan inverse of negative 1 by root 7. Tan inverse of negative 1 by root 7, and over here we will get what? Tan inverse of, when it is 5 by 4, 4 and 4 get cancelled, of course tan x, right? So 4 and 4 will get cancelled, and over here we'll be getting 5 by root 7. 1 by, this will become, you can take 7 by 16 common, you will have what? You will have tan square x plus 1, which is sec square x dx, and what will be its derivative? Its derivative will be equal to root 17 root 7 by 16, right? Root 7 by 16 sec square theta or x, right? This and this gets cancelled, and let me erase this. So this is what we had got, and it's very simple. The integral of dx is equal to x itself, and when you substitute the limit, you will get 4 by root 7. Sorry, this will be 4 by root 7 of the quantity x evaluated from tan inverse of negative 1 by root 7 to the quantity tan inverse of the quantity 5 by root 7, and you apply first principle over here. So we get 4 by root 7 times the quantity tan inverse of 5 by root 7 minus the quantity tan inverse negative 1 by root 7, correct? And now we all know that tan inverse of negative theta is equal to negative tan inverse theta, right? So we can write it as 4 by root 7 times the quantity tan inverse 5 by root 7 plus tan inverse 1 by root 7. So now let's evaluate this thing. Okay, let me erase this. Now how can we evaluate this? Well, you all must have studied about a formula, that tan inverse a plus tan inverse b is equal to tan inverse of a plus b divided by 1 minus ab, and depending upon some conditions You add a pi, you subtract a pi, or you don't do anything. So I don't think so that you should remember all that. Instead of that, you can just understand the concept behind that. So tan inverse of A plus tan inverse of B, we say that this is equal to tan inverse of A plus B divided by 1 minus AB plus some plus or minus theta. So I'll be writing, sorry, plus or minus pi, right? So I can write it as n pi, right? Now you all can ask me that why I have written n pi. Well, we know that tan of n theta plus pi is equal to what? Is equal to tan of theta, right? Okay, sorry, tan theta plus n pi is equal to tan of theta, right? Okay, so that is the concept. You are just adding two angles, right? And likewise you're solving. Okay, so this is this angle is also satisfying this thing, right? Tan of theta plus n pi. But why do we need to add a pi or we have to subtract pi? Because the domain, sorry, the range of tan inverse of some input, it is lying between negative pi by 2 to pi by 2, right? So for example, if both a and b are negative, if both are negative, then in that case it is possible that the sum will be less than negative pi by 2. Okay, so there's no problem till that time. But if their sum is greater than negative pi by 2, then in that case uh, this value will be always less than negative pi by 2, but here the sum is greater than negative pi by 2. So to compensate for that, we use a pi over here, n pi, and of course in that case you have to subtract a pi, right? And likewise, if you have both the quantities positive, for example, both are positive, right? Then in that case, if the sum is less than pi by 2, then okay, then you don't need to add any pi. But if suppose the sum is like, suppose this is pi by 3 and suppose this is also pi by 3, then the sum is 2 pi by 3, that is 120 degree. So, but over here this value can never be greater than pi by 2, right? So in that case you will have to use this quantity, this adjustment. Okay, so similarly over here, do we need some adjustment or not? We have to see that. And how we see that? We see it by seeing the product inside of these two functions. I mean, by seeing the input of these two functions, a and b, right? Okay, so over here a and b both are positive. Okay, so a and b both are positive. Okay, they both are positive. So we have to check if they are less than pi by 2 or not, their sum, tangent inverse of a and tangent inverse of b. We have to check that. Okay, so how we check that? Well, we check it by seeing this quantity. How? If 1 minus AB is greater than 0 and A and B are positive, then of course tangent inverse of A plus B by 1 minus AB will be what? It will be greater than 0, right? So in this case we have A and B as positive and we have 1 minus AB greater than 0, which means that this whole expression is greater than 0, right? So it means in this case you don't need any adjustment, right? But on the other hand, if suppose this is positive, but if their product, or I can say 1 minus AB was less than 0, then what was the case? Then in that case we would get A plus B as positive and 1 minus AB as negative. So this tangent inverse of this quantity would have become some negative angle. But notice one thing, this is positive, this is positive, so how can their sum be negative value? If this is positive, this is positive, how can its sum be negative? So to compensate for that, you need an adjustment of adding pi, right? Okay, so that is why over here we don't require any kind of adjustment. On the other hand, suppose if A and B were negative and suppose 1 minus AB was greater than 0, okay, then A plus B would have been what? They would have been negative, and 1 minus AB would have been positive. So in that case, we would have got this quantity as a negative value, right? So this is negative, this is negative, you are getting something negative. Okay, fine. If they both are negative and you have this quantity 1 minus AB is less than 0, then this is also negative and this is also negative. So negative divided negative will become positive. But how can two negative quantities add up to give a positive quantity? It's not possible. So in that case, you have to subtract a pi, right? Okay. And if A is greater than 0 and B is less than 0, then what will happen? Well, in that case, notice that tan inverse of A lies between negative, since it is greater than 0, so it will be lying between 0 to pi by 2, right? Of course, this will be closed, it will be open, right? Because if it will be closed, then what will happen? Tan of pi by 2 is not defined, it's undefined, right? And tangent inverse of B will lie between negative pi by 2 to 0, right? Okay, so far so good. So what can be the maximum possible sum between them? Well, clearly it will lie between negative pi by 2 to pi by 2. Clear or not? Let me explain you. This is going from 0 to pi by 2 and this is going from negative pi by 2 to 0, right? So if you add them, you will probably get, for example, if this is 0, okay, this is 0. And this is tending towards, suppose, the negative pi by 2. Let's assume for this case. So what will the sum? It will be equal to negative pi by 2, okay? And if this is tending towards, this quantity inverse of A is tending towards pi by 2, and suppose this is 0, then the maximum sum will be pi by 2, right? Okay. And when can we get 0? If they both are equal and opposite in magnitude. That is, if suppose this is 2 and this is negative 2, they both will add up to give 0, right? Like that. So in a nutshell, if you see the same sign over here as that in the case of tan inverse of A and tan inverse of B, then you don't need any adjustment. And if you see this is positive and this is positive but this is negative, you need adjustment, right? And since they both are positive, you will need to add a pi, and if they both are negative, you will have to subtract a pi, okay, right? And it is basically dependent upon this denominator, that is it greater than 0 or less than 0, and from these things only those conditions arise, that if both the angles are greater than 0 and if their product is greater than 1, less than 1, and all those kind of things, okay? So if you want, you can remember all those things. If you don't want, you can just remember the concept behind all that thing and how you get that idea, what to add, that is why to add pi and why to subtract pi. That is the idea, okay? So this is the concept behind that. Rest, it's your choice. If you want to remember the formula, good, and if you don't want to remember, that is the best thing, okay? So let me erase this and let's solve it now. If you want, I can give you a question also. For example, tan inverse of root 3 plus tan inverse of suppose 1, okay, this thing, okay? So clearly this is 60 degree and this is 45 degree, right? So this is 105 degree, right? So now just set it equal to what? Tan inverse of A plus B root 3 plus 1 divided by 1 minus the product of these two things, that is 1 minus root 3 into root 3 into 1, that is root 3. Now you can clearly see root 3 plus 1 is greater than 0 and 1 minus root 3 is less than 0. So this is a negative quantity and this angle is positive and this angle is positive, right? So in that case, you will have to add a pi, right? As simple as that. And suppose if you had negative angles over here, what you would have got? Negative 16, negative 45, right? So in that case, it would be negative 105 degree, okay? And over here, you would get negative root 3 minus 1 divided by 1 minus root 3, right? You would get this thing which would become root 3 plus 1 divided by root 3 minus 1, and that thing would be positive. So how can two negative quantities add to give a positive quantity, right? So in that case you would have to subtract a pi. Okay, and suppose if it was root 3 and this was negative 1, then in that case it would be 60 minus 40, that is equal to 15 degree. Okay, so tan inverse of root 3 minus 1 divided by the quantity 1 plus root 3. In that case it would be root 3 minus 1, that is positive, and over here 1 plus root 3, that is again positive. So over here we had a positive angle, and over here also we are getting positive angle, so no need to subtract or add anything, and that was obvious also. So clearly now that was all just theory for your reference. So 4 by root 7 times the quantity, this is tan inverse of 5 by root 7 plus 1 by root 7 divided by the quantity 1 minus 5 by 7, correct? You get this thing? Now 4 by root 7 times the quantity tan inverse of this will be 6 divided by root 7 times 7 by 2, right? So this is 3, and this is root 7, right? 7 is equal to root 7 into root 7, right? Okay, so we have 4 by root 7 times the point tan inverse of the quantity 3 root 7. Is this the answer? No. Answer is we will get answer when we multiply by pi by 8, right? So we will get the final answer as pi by 8 times the quantity 4 by 7, 4 by root 7 tangent inverse of the quantity 3 root 7, 3 root 7, and when you multiply you get, so the final answer is pi by 2 root 7 tangent inverse of 3 root 7, and that's the answer. Okay, so this was a very nice question for understanding many things, right? In this you applied many concepts, and I think that I taught you many things extra also, which no one would have taught you, I guess, because no teacher is, whatever I am observing, no teacher is following the conceptual approach. They are just teaching you formulas so that you can score in exams and all those things. I know examinations are very important, but I don't think so that for those examinations we should disrespect the subject. We should always go to the crux of that subject and discuss each and everything from very basics to whatever level you want. For example, there is a very interesting thing in master's mathematics that is very high right now, because this was of 12th, but let me explain you. There is something called as gamma function. Gamma of n is given this as this integral t raised to the power x minus 1 e to the power negative t dt, right? So many students just learn these formulae, I mean this one formula, and they expect they will do all the problems. Is it possible? No, because it has one more form. If you want to know, you can know it. Limit as n tends towards infinity of the quantity n raised to the power x n factorial divided by n plus x till x, right? Okay, so it's not of your level, but still I'm telling you. So this is another form, and it has one more form also, but okay, let's leave it. So students mostly learn this formula without even derivation. They don't even derive it, they just learn it. Okay, but from here you can easily go to this form if you know its derivation, and if you know the definition of e to the power t. And e to the power t, you must be knowing what is it. E to the power negative t is the limit as n tends towards infinity 1 minus t raised to the power t by n raised to the power n, right? If you know this definition, you can clearly go from, you can easily, it's not like very difficult, you can easily go from this to this form, right? But that is the problem. People don't follow the conceptual approach, they follow the formula approach, that we will learn this formula, we will do these problems, and then it's okay, we will crack that exam, we will do that. But I don't think so that is the right approach, because after all, whatever exam you are giving, the selection rate is very low, because of course Even if everyone gets full marks, it is not possible for everyone to go to that place where they want, because clearly it's not about how many marks you are getting, it's about how many seats are there and how the people are performing in that examination. So for me, any person who has more knowledge or is conceptually strong is much better than any person who has cracked any examinations or has multiple degree. I don't care about that. So with these lines, I would like to end the video right now. Bye bye, take care.